You're listening to MANX Radio, and I'm Judith Lay, welcoming you to the podcast of the MANX Sky at Night with Howard Parkin.
The nation station, MANX Radio.
Twinkle, twinkle, little star, how I wonder what you are.
We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
And that familiar music reminds us that it is time for us to say Faster Mai and welcome to the man with the knowledge. It's Howard Parkin.
Hi Judith. Yes, it's great to be here once again on the MANX Night Sky here on MANX Radio. But before we start, I'd just like to say a huge thank you to everybody who's expressed concern about my knee replacement surgery I've just recently had. I've been overwhelmed with messages of good luck and everything else, and it's really nice to hear. And thank you all very much indeed for doing so.
Well, get well wishes are always welcome, aren't they, Howard? Now, come on, what have you got for us?
Well, Judith, I think having my leg done at this time of year was a brilliant idea, because it means I can't go out doing any stargazing, so I can sit and read my books and write stuff. So that's what I'm planning to do for the next few weeks until I'm back on my feet properly. But it's a strange time of the year for astronomy because, of course, the sky is just so light. I think I've mentioned this before. We don't get beyond what we call astronomical twilight from the end of May right through to the beginning of August. That is that the sun is less than 18 degrees below the horizon. So we don't get, as I say, dark skies at all. If you're interested to have a look, if you're up at 1, 2 o'clock in the morning, look towards the northern horizon and you'll see clear signs that the sun is not that far away. If you're in Edinburgh, we don't even get beyond civil twilight, which is when it's about 10 degrees, I think it's 12 actually. So we are lucky from that respect. But it doesn't mean there's nothing we can not see in the night sky. In fact, in some respects, it reminds me of when I used to live in Liverpool as a young lad. The only thing you could see from Liverpool, even then the light pollution was pretty bad. So the only thing you could see were the very bright stars. And it's the same at the moment. We can only see, because of the lightness of the sky, we can only see a number of very bright objects in the night sky. There are a number of stars, not particularly a lot of stars, but there's a number of stars in the night sky that can be seen, and just literally on their own, isolated on their own, we can see the star like Spica in the constellation of Virgo, and Regulus in Leo, Arcturus in Boötes, and of course the stars of the Summer Triangle, which I'll talk about in just a moment. So the idea is, if it's dark and you're really looking around midnight now, you're not going to see much before midnight. If you're outside, maybe you're coming home after watching the races or whatever, and you just see it's a beautiful clear night like we've had the last few weeks, and fingers crossed we're going to get great weather for this TT, you might just see, wonder what that star is. And it's not particularly difficult to identify them because they are so few and far between. The first ones I'd like to mention for you is the star Arcturus, and the star Arcturus sits on the northeastern horizon. And this is easily found by finding the stars of the Plough. Now, the Plough, not easy to see. The stars are relatively bright, but they're more or less overhead. It's sort of standing on its tail overhead at this time of the year. And the curve of the handle of the Plough curves down to and points to the star Arcturus, which is a really nice bright star, fourth actual brightest star we see in the Manx night skies, or indeed in any night skies anyway. It's the fourth brightest star in our skies. And then that line you've just followed along, follow that along the eastern horizon now and towards the southeastern horizon, and you'll come to another bright star, and that's the star Spica. And Spica is a lovely named star. Spica is the star that's the principal star in the constellation of Virgo the Virgin, but also known as Astrea, the goddess of the harvest. And Astrea, the goddess of the harvest, of course, denotes the fact that this constellation starts to get visible in the early summer and is at its best and most easily visible in the northern hemisphere in September, at the time when the farmers are cutting the harvest, which leads us back to the harvest moon in September again. So the star Spica is named from a spike of wheat, and the spike of wheat in her hand is named Spica. And that's where Virgo the Virgin comes from, which is, of course, one of the signs of the zodiac. If you now move upwards, you've found the star Arcturus and you've found the star Spica. If we now go upwards to sort of make a sort of an equilateral triangle, you'll come to another star. And this star is going to be quite easy to spot because there will be two stars in that location. One of them will be a lot brighter and very red in colour. That, of course, isn't a star. That's the planet Mars. And the planet Mars, very close to the star Regulus, which is the principal star in the constellation of Leo the Lion, gives us an unofficial spring triangle, or a triangle of stars you can see in the late spring, early summer. Nothing to be confused with the summer triangle, which we probably won't talk about today. We'll probably talk about that next month when we're talking about the different features we can see in the summer sky. But Mars, of course, it's fascinating to look at the planet Mars, because Mars, not that long ago, only a few weeks it seems, it's probably actually realistically about March time, we had the planet Mars very, very close to the two principal stars in the constellation of Gemini, the twins. Some of you may recall we had a lot of planets visible in our night sky, and all of those planets were all sort of centered roughly together, although it was a bit inaccurate. The coverage of that was a bit inaccurate. But we did have all the planets visible at one time in the night sky. Now, Jupiter and Mars were very close to each other. Jupiter was actually in Taurus and Mars was in Gemini. Now, wind the clock back 3 months or forward 3 months, and we now found that Jupiter just about visible in the evening sky in a very light sky, very difficult to see, and frankly, don't bother. But that is now moved into the constellation of Gemini. In the meantime, Mars is shooting backwards across the sky, but still setting in the west, which sounds a bit contradictory. But as Mars is heading westward, so the Earth is turning on its axis and going around the sun, which means that Mars continues to travel westerly, but it's moving in an easterly direction across all the different constellations. And what's happened, Mars has gone from Gemini, and now Mars is whipping through. It's gone through the constellation of Cancer, and it's now arrived in Leo. And it won't remain long in Leo before it heads into Virgo, and then onwards to the other constellations along the zodiac, before it finally loses out and the sun catches up with it, and it will go behind the back of the sun in January next year. Jupiter, in the meantime, goes through what we call its conjunction with the sun in only a matter of weeks' time, I think in early July. So this motion, this feature we see in the night sky of the planets moving around very quickly, just throw your minds back now to ancient observers all those many years ago. They didn't sit at home watching TV and listening to Manx radio. They basically, when it was dark, they probably slept, and when it was daylight, they worked. But in the evenings, on a beautiful evening, they would see that these objects were moving around the sky in a strange, unpredicted fashion. And that strange, unpredicted fashion was what led to the idea of astrology, and the fact that the planets go through these wanderers, which is the Greek word, planet is the Greek word for wanderer. And the idea was that these had some connection with our life on Earth. And it's no coincidence that Jupiter actually goes through all the signs of the zodiac in 12 years. Jupiter moves one sign of the zodiac every year. So all these connections made people think that the stars had something to do with our life on Earth and could predict things that were going to happen. And that was the case for many, many hundreds of years. And it wasn't until Copernicus and Galileo and Newton and all these people realized that they can actually work out why the planets move the way they do is because the Earth goes around the sun and not the other way around. So as you go outside and you see just these odd bright objects, those are the stars. But when you see the bright Mars not far from not as bright, but noticeably one of the stars, star Regulus in Leo, you're starting to see some of the features that the ancient Manx observers would have seen from their Celtic roundhouses and wherever they were on the island all those many years ago.
Do you know, the past is every bit as fascinating as the present, isn't it? Now, come on, Howard, what are the chances of any noctilucent cloud activity in the coming weeks?
Yes, noctilucent cloud season is upon us, and the noctilucent clouds are one of the compensations we get for this particular time of the year when the sky is very light. Noctilucent clouds are caused by very, very high up clouds, thousands of feet high, way up in the sky, and they are lit by the sun. So what you're having is the sun is below the horizon, but the clouds are still being illuminated by the sun because they're so very high up. And these really are quite fascinating objects. Something I'd never seen myself until literally about 5 or 6 years ago when I'd never seen one. Then somebody pointed them out to me and I realized how wonderful they look. So you have a lovely sunset evening. It's about 11 o'clock, 10, 11 o'clock, after the sun has well gone down. And you look up in the sky and you've got a beautiful sort of dark blue sky. And all of a sudden you'll see these silvery grey objects, which look like clouds, but they're smallish because they're high up. And they have weird patterns in them. And they really are quite beautiful. The best description I've ever heard of them is an ethereal blue, electric blue ethereal clouds. And they really are quite dramatic. And there does seem to be an increase in the amount of noctilucent clouds we're seeing. Obviously, some of that might be to the fact that astronomers are now pointing these out and making people aware of them because they are a feature we see quite clearly in the night sky at this time of the year. But there is a theory that these clouds are seeded, if you like. They're seeded by ice crystals up in the upper atmosphere. And these ice crystals are increasing as global warming is increasing. Then the prevalence of these clouds is increasing because there's little tiny ice crystals in the clouds, and these ice crystals reflect the light far more so than perhaps if a lesser amount of ice would be up there. There's also a theory that it's caused by meteoric dust. When meteor showers come into the Earth's atmosphere, this dust sometimes is captured into Earth orbit, and you get these clouds of material which we don't really see at all. But there is a theory that these clouds, these noctilucent clouds, are caused by that sort of feature. The word noctilucent, it's a lovely name. It's one of these names we love to throw out when we want to impress people, but it means night shining. And that's what noctilucent means, night shining clouds. Noctilucent cloud season starts at this sort of time of the year when we go through when there's no twilight hardly, and we see these clouds very beautifully shining on the horizon. I'm reminded of a time when we were at the observatory a few years ago when we had Nicole Stott and the space shuttle crew up with us. This was in 2012, and it was Tynwald Day, so it's the sort of same time of the year, and we knew the International Space Station was going over, so we all went outside, and Nicole was waving to the crew on board the ISS. They didn't wave back, though, miserable lot, but she was waving to them, and we were all outside looking and seeing how beautiful it was. It was a lovely evening up at the observatory, and then sure enough, that was one of the first times I ever got to see noctilucent clouds. Very, very clear, very, very visible, and a wonderful memory of a time when, as I say, the Space Shuttle Crew Discovery came to see us for the Tynwald Day ceremony in 2012, and they visited us up at the Isle of Man Astronomical Society Observatory.
Howard, I think you would have got a bit of a fright if you had a wave back from the International Space Station, but great story. Now, come on, we're just on the threshold of TT practices starting. Surely you've got a bit of a TT connection for us, have you?
Well, I'm glad you asked me that, Judith, because I have nothing but admiration for the TT riders. The speeds they throw those machines around the Isle of Man is scary. I mean, I wouldn't want to drive a car anything like the speeds they drive at, and I've got a big cage around me. But no, they are very, very good, and they're very, very skilled, and I think it's an amazing event, and it's become worldwide now. And many's the time I'm talking to people, and they'll say to me about the TT races. I think that's been brought about by the advent of all this digital television now, and you can watch the TT literally only hours after the races on the various TV channels. And that, of course, is seen around the world. But, you know, when you think about astronomy and the TT races, there's a huge link, because there's one thing that astronomy does that the TT riders do, and that's speed. When we consider the speed that our planet goes around the sun, and we consider all the other objects in our solar system, these TT riders, they're going slowly by comparison. One of the planets we see in the night sky, which isn't very easy to see, and this time of the year it's practically impossible to see because it is so close to the sun, is the planet Mercury, the winged messenger god. And of course, anyone who knows anything about the TT knows about these wonderful TT trophies. And on the top of every single TT trophy, and indeed every replica, has a depiction of the goddess Hermes. And Hermes, of course, is the winged messenger god, also known as Vulcan, also known as Mercury. Now, I mentioned the laws of physics before when I talked about how the planets orbit the sun, and we look at them and we know what they're going to do and everything else. Well, it was Kepler at the time of when Galileo and Kepler and Copernicus and all these people were working on what made the planets move. It was Kepler that came up with what we call the laws of planetary motion. And the planetary motion laws, amongst them all, I won't go through them all now and put everyone to sleep, but the most important one is, or one of the most important, is the fact that an object near to the sun, or a star, the nearer it is, the faster it will go. So you think we're going faster on the TT course at what? Probably 200 mile an hour at certain places. Well, Mercury travels every day, all day, at 107,000 miles an hour. That is the orbital speed Mercury has to maintain its orbit around the sun, which of course it's been doing for many millions of years. Not far out from Mercury, of course, we've got the planet Venus. We'll ignore Venus for the moment and come back to that in a minute. But the Earth, of course, that goes around the sun at 66,000 miles an hour. And if you're not just happy with that, the International Space Station in orbit around the world goes around the world at 17,000 miles an hour. So when we think about speed, these TT guys might have it, but we're all traveling, as I say, at 66,000 miles an hour on our orbit around the sun. And incidentally, we're also spinning as the Earth rotates on its axis. It depends where you are on the world, but the rotational speed of the Earth is about 1,000 miles an hour. So we've got the speeds. We don't have the effect of whipping around Craig Nabar or Ramsey Herpin, of course, but they're very great speeds. And that, of course, is science. That's the whole point. And that's when you start considering these things and you realize that the numbers and the speeds involved, they are astronomical. And that word is entirely appropriate. But it reminds me of another TT story, and we don't have morning practices now for a whole host of different reasons, which I won't go into. But some people may recall, those TT fans may recall, many years ago when you went up round Ballaugh, that sort of area, there was a huge, massive TT sign that said, "Beware sun." And of course, when you were whipping around the TT course on an early morning practice, and when you headed up between Ballaugh and Ramsey, you're heading east. And of course, the rising sun could cause problems. That's why that big notice was put there. I don't know what that happened to that notice. It should be in a museum somewhere, really. In fact, I must ask the museum about that one, because that would be one that is certainly a collector's item and worth talking about, because the sun, of course, had that effect of causing problems for the riders all those years ago when we had those early morning practices. And with that in mind, Judith, I think we'll go for the song "Here Comes the Sun" by the Beatles for our song.
I think it's a great idea, Howard. And here it comes, the song and hopefully the sun in the morning.
Here comes the sun, doo-doo-doo. Here comes the sun, and I say it's alright. Little darling, it's been a long, cold, lonely winter. Little darling, it feels like years since it's been here. Here comes the sun. Here comes the sun, and I say it's alright.
You're listening to this month's edition of the MANX Sky at Night with Howard Parkin, and that was Howard's music choice for us, the Beatles, and Here Comes the Sun. So, after talking at quite great length about what we can expect to see in our Manx skies in the coming weeks, Howard, have you got some space news for us now?
Yes, turning now to the space news going on in the night sky at the moment, and it never stops. I actually was thinking only a few days ago there wasn't much going on, and so I just looked up on the internet what's going on in the world of space. And of course, the big story is going to be next week, or at least I hope it's going to be next week. Elon Musk's Starship, or Elon Musk's SpaceX company, are going to launch the 9th version of their Starship. Now, the last two launches went very well in that the first stage was able to be recaptured by them, but the upper stage exploded both times. And this is, of course, the upper stage, which will have the second stage and the Starship itself, which is the one they're going to use to initially take people into orbit, then people to the moon, and then onwards to Mars. And I understand from the media that Elon Musk is going to make a statement about his plans for exploring Mars before the launch of Starship 9, which is at the moment currently planned for the 27th of May. So literally only in a few days' time. But in the meantime, we look forward to seeing the launch of Starship. And if it does go ahead, this time they're going to try and capture the lower stage again. And then I understand they're also going to try and capture the Starship when it's been around the world and done one orbit. They're going to have a try and catch it, or at least land it safely into the Gulf of Mexico. To me, it's still the Gulf of Mexico. And that's the plan for Starship. Now, this is all subject to Federation approval and all sorts of things, and of course the technical side of it. And we'll wait and see. But this is only the 9th launch. They've had 8 launches so far, literally in only about 2 or 3 years. So the rate of progress, the development of these missions has been very, very rapid, far more rapid than you'd expect in the space industry. With NASA, for instance, who are far more, I think I would use the word cautious, but of course, with SpaceX, what they're doing, they're learning very quickly from what goes wrong and then starting again. There's no danger, there's no problems. Yes, there's environmental impacts being assessed every time they do a launch, and quite rightly so. But of course, they want to get on with it. The whole idea of going to the moon, going back to the moon, which is now tentatively slated for 2027, is very dependent on Starship, not just getting into orbit, but the spacecraft being fitted out as our landing vehicle for going to the moon. The plan is to go to the moon in an Orion spacecraft and rendezvous with the Starship lander, and then land on the lunar surface, as I say, sometimes in 2027. I still think that's a bit ambitious, and I'm not so sure it's going to happen by 2027. But I'm relatively confident we're going to certainly get back to the moon, I would think, by the very latest 2030. And then, of course, the next goal is to go to Mars, and that's what Elon Musk is going to be talking about. I understand at a press conference he's going to call in this next week or so. At the same time, we've also got another SpaceX mission taking place, and this is the Axiom 4 mission. The Axiom 4 mission, listeners may recall the fact that as well as the SpaceX Dragon being used to ferry astronauts up and down to the International Space Station, there have been a number of private space missions now using SpaceX Dragon's spacecraft. The Axiom missions, this is their 4th mission. There's also been the Polaris Dawn mission, and there are others planned as well. But the Axiom mission is particularly impressive because what they're trying to do, the Axiom missions, is to actually take people into space and bring them back again. But what they want to do ultimately is to build a small space station, attach it to the International Space Station, and then when the International Space Station can be used to help give it supplies and get used to using it and all the rest, but when the International Space Station ceases to be operational and they have to deorbit it, they will detach the Axiom part of that, and that will become a free-flying, independent International Space Station. Incidentally, the talents of the guy who's been setting that up, the Axiom company in particular, Jared Isaacman, he is being put forward as the next administrator of NASA by President Trump. And that has yet to be approved, but is highly likely to be going to take place. So we wait with bated breath to see the launch of Axiom 4, which is scheduled at the moment for the 6th of June. Again, these dates could change very easily, so we'll just have to wait and see. But exciting times. And then just to throw it into the wings, we've got the Japanese are launching a spacecraft. I don't know the exact date yet. They haven't given us the date, but they're sending their Tian-1 spacecraft. So I said Japanese, I meant Chinese. The Chinese are launching their spacecraft to a comet, and this is going to get some samples of material from this asteroid. So I said comet, I meant asteroid. They're going to get some samples from this asteroid and bring them back to Earth. Now, this is very important. We did it with the Bennu mission, the OSIRIS-REx Bennu mission a few years ago now. And when we analysed the data and the material that had been brought back by these spacecraft, we're looking at material that literally predates the origin of our Earth. This is material that was formed in space at the time when the sun started to shine. And when we start looking into the detail, you then start to think about where the water came from and all the rest. All very exciting stuff. And it's all going on at the moment. And it's great that we can talk about it. And there's always something going on. And there's always something we can talk about.
Indeed there is, Howard, and you managed all of that, scarcely pausing for a breath. The bad news, Howard, is that we have once again been beaten by the clock and we're all out of time. But thank you very much indeed for joining us for this month's edition of the MANX Sky at Night. Howard, it just remains for me to say thank you very much indeed.
I do look forward to being back in the studio in June. And again, thank you to everyone for your very best wishes. Fast am I, and I'll see you next month.
Fast am I, Howard Parkin.